Graph the system of inequalities. Y is greater than or equal to x minus 1, and y is greater than or equal to negative 4x plus 1. So we'll start off by treating each of these as equations, and then we'll handle the inequality portion of this in just a moment. So let's start with the first one. And I have y equals x minus 1 as an equation, which would have a y-intercept of negative 1 and a slope of positive 1. So if I go up 1 and over 1, I can get more points on the line. So here's my line. Now, this line can either be solid or dashed. And the way I determine that is through the inequality used. If it's less than or equal to, I would use a dashed line because that represents the exclusion of the boundary. But since it's greater than or equal to or less than or equal to, that represents inclusion. So we would want to use a solid line here. All right, so I'll just draw a solid line right through these points. And lastly, I need to decide which way I'm going to shade. So I pick a test value, and if the origin is available to use, I'll use that. So if I use a test value and plug in 0, 0, I would have 0 for y is greater than or equal to negative 1 because your x is 0 as well. 0 is greater than negative 1, so that's a true statement. So then what you would do is shade the side of the line that contains the origin. Okay. Now we go to the other line, which is y is greater than or equal to negative 4x plus 1. And what we do there is the same thing. We have a y-intercept of positive 1 and a slope of negative 4. So I come down 1, 2, 3, 4, 1 to the right, down 4 and over 1, or up 4 and back 1. That's fine as well. This is also going to use a solid line. So I'll just draw in a solid line that fits those points pretty well. And now I need to decide which side of the line is going to be shaded. And I can again use the origin for a test. So if I plug in the origin, that would give me y is 0, greater than or equal to 4 times 0 is 0, then plus 1. So we have 0 is greater than or equal to 1. So that's not true. That's a false statement. And what that means is we shade the opposite side of that line. So the side that does not contain the origin. So there's the solution region for that line. The solution region overall is where these two different solution regions overlap one another, which is going to be right through here. And I'll do it in a different color so that it shows up a little bit better. And if I erase these, that should make it make a little bit more sense. Now, sometimes these questions will ask you to identify a few points in the solution region. So pick easily identifiable points here, so that you don't end up accidentally giving the wrong coordinates or something. But like there's 3 points in the solution region, so 0 on the x and 3 on the y, 2, 5, and 4, 4. So those are some points that exist there, and you could use any point as long as it's within that shaded region. Okay, so this is certainly a different set of line equations, but the way we do them is the same. So the first line equation is y is greater than x minus 2. So you want to choose a dashed line or a solid line based off of the inequality. So you want a dashed line. Then what I would recommend is pick the point that is your y-intercept, so negative 2. And then we have a slope of positive 1. So then up 1 over 1, that gives me another point on the line. I'm done graphing the line. Now I just move my pencil here, that's on screen, into one side or the other. And that's where you just have to do the same sort of test to decide which way it's going to go. So if you choose the origin and plug it into this equation, you would get 0 is greater than -2. Since that's a true statement, just click there, and now that will stay shaded, and you finished graphing that line. So then the other line, y is less than -1/2 plus 1, it's also a dashed line, has a y-intercept of +1, and a slope of -1/2, so go down 1 and over 2. And then you have to decide which side of the line you want to graph or shade. So we'll try the origin again. So that would say, if you plugged in the origin here, that would be 0 is less than 1, which would be a true statement. So there you go. Now when you click, it will stay and you've graphed it. So at this point, the overlapping regions, which are in purplish here, that's the solution region for the system. So if I submit this now, there we go.